For the newcomers who haven't seen F# before, I'm really looking forward to taking you through some of it. Today is going to be about not just about F# as you can use it today. It's also going to be about F# as we're shaping it for the future. It's very much a 50-50 talk about exciting things you can do today and exciting things you can do in the future. And it's been such a privilege and a pleasure to be able to bring this language to the Visual Studio audience. And it's in there in Visual Studio 2010, and it is such a powerful tool in the hands of people using it well. And we see that I'll take you through some of the case studies today about people who've been using it in practice in the enterprise very effectively, very often. And it's also a lot of fun to very code-focused language, a code-focused programming experience for solving problems. And I know that's, there's all sorts of great tools being shipped by Microsoft, lots of great language tools, but I know that code-focused kind of experience, programming experience, is still very critical to many practicing developers and analysts. And so let's get going. So this is really about the second half of the talk. It's about the future of F#. So I just want to give you a taste for where we're heading in that second half of the talk, to whet your appetite for that. And that part, that's a very simple concept that we're going to be getting across there. And I want to just take you through some very, very, this is like these sort of arguments where we take you through several propositions, and by the end of it, you've bought the Brooklyn Bridge or something you bought. The world is information rich, right? We use that, we experience that every single day. We all, with the internet, with the web, with our mobile phones, with our enterprise applications, it's an enormously information-rich world. And applications are incredibly information-rich. When we have a traffic application on the phone today, it's tied to particular data sources, tied to particular web services or OData feeds or whatever else it's REST APIs or whatever else it's drawing on. And it's always been the case for enterprise applications. And there's a sense in which our languages and our frameworks are in some sense kind of information sparse. There's not a lot of, you don't find a lot of raw information. You can't find a list of football players in the .NET framework libraries. You can't find a list of chemical elements or the latest information about baseball games that are happening, or historical information about stock prices or whatever information. It's not quite there. You've got lots of bits and pieces for doing things with information, but we don't have the information itself really in our hands. And this is a problem. It's a particularly big problem for statically typed languages like F# and C# and Visual Basic. There's always this big impedance mismatch between us in our language, in our lovely type systems, and that we use to tame the shapes of data. And that applies to C# very much to F#, that you want this. You want data in a strongly typed form so you can transform it and apply this wonderful functional programming, apply your LINQ kind of ideas to kind of querying and working and shaping and transforming and republishing the data. But if you haven't got the data in the first place, that's kind of a problem. You're not connected to your information. And there's lots of tooling in Visual Studio to help you with that. And we're going to take a look at a very code-focused addition that we're doing to F# to really explode the amount of information that you have available in the language. So the future of F#, looking ahead, is about marrying functional programming with immense information richness. And so I sometimes characterize that as functional programming superdrug meets information-rich world. And this wonderful combination that happens when we draw these things together. We've had a taste of that combination in LINQ. We've had a taste of that combination in F# 2.0. And we're heading towards a world where we're marrying these things even more closely together and more fluently together. And we're going to apply a little bit of magic, which is always important in language design. When you put things down at the language level, these things can a lot of complexity can disappear when you put async programming into F# or into C#. Many of you have probably just been to a C# async talk. I think it's been earlier today. And you know, it really feels there's a lot of it's not, you know what's going on. It's not really magic, but it's very effective devices to add to these language designs. And the thing we'll be adding to F# is called type providers. And you can think of type providers plus LINQ as kind of giving you this sort of language integrated data and services. And but before we go in that direction, we're going to do the first half of the talk, which is going to be all about you know, what is F# 2.0, as you can get it in Visual Studio today. Why should I care? Let's take a look at what people are doing with it and all sorts of questions like that. Okay, so as you know, it ships with Visual Studio 2010. I'm sure many of you in the audience are actually using it today. I've met some of you, and that's great to know. People often say learning F# is one of the best things you can do for your general programming skills as well. So it's got many different roles on the platform. It's got a role as a high productivity tool. It's got a role as a lead language for ideas that come into C# and Visual Basic. And it's got a role in education kind of role as well. And you see that coming across into sort of academic education agenda around F# as well. So F#, this is how we like to describe it, right? Sometimes we try and reduce this down to say, to the number, you know, to make it even smaller. And then we realize we've left out some key adjectives along the way. So I just yesterday put back in interoperable, a productive, supported, interoperable, functional programming language. And yeah, this is that allows you to write simple code to solve complex problems. That's that's our kind of mission statement. That's what we're after. Now, as I was mentioning this word interoperable, I think sometimes people can leave an F# talk, and normally when all the demos I'm going to do today are going to be scripting with F#, because that's just the best way to give demos, right? Because you can get more stuff going and done. People can leave an F# talk without realizing that it's a statically compiled language. You have projects, you can create binaries, you can create exes, create DLLs, you can create just normal .NET components, just like a Visual Basic or a C# component with a lovely little API, with your lovely API that a good .NET component should have, and integrate that into a larger C# or Visual Basic solution or application. We see that quite often, applications where 30 projects are C# and 1 or 2 are F#. Totally great. We love that sort of use of F#. Yes, the interoperability, the fact that it's so smooth to interoperate between C# and VB, between C# and F#. It just, it's very, very important to remember that this is just a .NET language, but a different kind of .NET language in the sense that it's got different strengths and aim for different kind of uses. But at a technical level, it's very familiar. You know, if you want to get to know F#, there are several different ways you can approach it. But some people just like to compile up some F# code and pull out Reflector, pull out ILDASM, and take a look what we actually generate for the .NET code for any of what we will be looking at today. I'd really encourage you to try that, and it'll give you a feel for what the language actually sort of is at a technical level. Okay, so simple code, strongly typed. So these are a set of slides I use just to make some comparisons between F# and, you can look at it as between functional programming and object-oriented programming. I'm going to use F# and C# syntax. In this first example, you could do this with C# delegates, but the point that I'm making is between functional and object-oriented programming. So this is sort of one of the gang of 4 design patterns from the object-oriented world. It's the command pattern. We maybe are doing a simulator where the command is something that just just acts on a rover and changes it in some way, like accelerates or rotates. We have 2 commands. We have a type of commands, which is just something which takes a rover, and unit means void in F#. It's just like a void, but you can actually use it as a return value. And it's just, you can think of that as void is here. And we have a break command, which is a command which takes a function, which takes a rover, which accelerates the rover backwards, and a turn left command, which takes a rover and rotates it by -5 degrees. There. Okay, that's nice and declarative and simple, and that's how we want our code to look. And if you used C# delegates, you could also make it look like that. But if you go back to Java, for example, or to the object-oriented kind of land, and you pull out your design patterns and you start to code it up, right? You start to go, this kind of thing, right? You have to do your abstract class of commands, and this is what the design pattern tells you to do. And then you think, you're thinking hierarchically, you're thinking modeling. And people tell me that, they kind of say, oh, functional programming, I need to, I want to learn it, I can't quite get into it. I think, well, it's so much easier than there's all this inheritance kind of modeling and thinking in kind of this assembly code over on the right here. Because let's look, you have to think so much. You have your command, and you've got your rover that extends your rover command that's going to capture one of these rovers. And then you think, okay, we're going to have different kinds of commands, and you probably insert a few more layers in your hierarchy, and then you get a break command, the rover command that takes the rover and puts it into the rover, and then it overrides and executes and rotates, and eventually you get some code, some logic right somewhere in the middle of your object-oriented modeling. Now, F# is not anti-objects. It embraces objects in many, many places, and embraces a sea of objects underneath. Often you'll be doing functional programming over this sea of objects. We'll see many examples of that. And it certainly embraces the dot notation. You see rover.accelerate, fine by F#, that's just no problem. We embrace objects as a design technique, and we've got nothing against the design pattern here. The idea of the design pattern is fine. It's just the encoding into the sort of object-oriented class hierarchy world is not particularly F# idiomatic over on the right. So let's take a look at another, what to the F# programmer is a very straightforward bread and butter kind of programming problems. We take a tuple of data and we swap the elements to return a new tuple. We take rotations of a tuple here, x, y, z, and we generate a list containing the 3 rotations of the tuple, and maybe you can use those to permute the arguments for test cases. For example, you're going to take a permutation of some inputs and a permutation of some other inputs, combine those together, generate a whole bunch of tests, and carry on. Fairly straightforward work. Same with f, x, y, z. Maybe this is the expected answer from a test. You're taking some function, it's going to take the elements, and you're going to apply the function to each element and add up the results. And you program this up in, say, C#, and C#, I'm probably the key architect on C# generics in conjunction with the product teams and Andrew Kennedy back at the start of the last decade, and we're very happy with what we put into C#. We use it all the time in F#. The F# code over on the left compiles down to something reminiscent of the code on the right. It's not exactly the code on the right, but this is the sort of thing you have to do in C# in a way. You just probably wouldn't write this because it's kind of a bit too painful to write. To put on all the types and the read-only collections and the new tuples and so on, it doesn't feel idiomatic. But to the F# programmer, they can chew up problems by of taking data or generating test cases. Let's take that. It's such an easy problem to the F# programmer because the language is just built for constructing shapes of data and manipulating them and piping them through, pushing them through to whatever the target of the data is. Okay, so that's sort of constructing data in lists and tuples and functions and generic functions to work with those, and it's a bread and butter of functional programming. Now, F# is not just about that sort of programming in the small kind of thing. We've got these enormous themes running through the industry, and it's allowed us to shape a language which is sort of right for the time. It's got the right language elements in it to allow you to take both the functional programming that we have and a set of elements to tackle these kind of problems in the set of elements in the language itself. These two enormous themes running through the industry, the web and the cloud, and multi-core programming that will continue to wash through the industry over the next 5, 10, many, many years. And one of the things we have is these beautiful sub-languages for doing parallel programming. We do parallel input-output, overlapped I/O, task-based I/O. You can convert these asyncs into .NET tasks. You can think of them as being ways of generating .NET tasks with a nice syntax in the language. And for instance, we're taking three gets of 3 web pages here and executing those in parallel, and then doing a fork join and waiting for the results to come back. And it's a very compositional model of parallel programming, so that you compose a parallel composition, and you also use what we call a workflow syntax in F#, which we won't be showing that much of, but it's we'll see a couple of examples later on for these asynchronous workflows that give you a very declarative view of asynchronous programming. And this is, of course, the feature that's been taken into C# and VB in a different form, sort of a lower level form, I think a less declarative form. There's some advantages to that and some disadvantages as well. But this is a lovely parallel programming model for parallel I/O, overlapped I/O, and it's very much in tune with the move to the web and the move to the cloud. You can use the same sort of constructs for parallel multi-core CPU programming. Again, it's a task-based. You have some set of compute tasks here, and then you create, say, 201 of those and put those in parallel, or create 2,000 of those, and we run through the usual .NET infrastructure for executing in parallel through the thread pool and through tasks. Again, you do a composition, and then you press the run button on the outside to execute your parallel composition. Okay, so let's take a look at using F# 2.0 in practice. I'm just going to run through one of my favorite little examples of scripting with F# 2.0. So here we have Visual Studio 2010. We have our Twitter feed script, twitterfeed.fsx, and we have F# Interactive down below. So I'll reset that session. And you can find you can use F# Interactive from any project context. So don't be afraid if you're working in a C# project and you want to have a script to test the DLL you're creating. Don't be afraid to create an F# script and put it into that C# project if you're able to do F# scripting from a C# project context. And let's load up these scripts here. And so what we have here is a couple of helper scripts which define just an object which lets us have a stream of tweets from Twitter. So we have a type here. This is defined as object-oriented programming in this Twitter stream file. And we also have a username and a password being defined in this Twitter password file here. So we can execute this line here, and we have our Twitter stream. Now, what's this window over on the right? This is our show window. So you'll see me using this show function quite a lot. And what we can do here is, say, for instance, take the numbers from 0 to 99, and we call the show function on that. And that will take the numbers, that list of numbers here on the left, and format that data, that object, that data over on the right-hand window. So similarly, we might take a tuple 1, 2, 3, 4, and show the tuple here. And we'll also use this sort of syntax quite often. So we might take all the numbers from from 0 to 99 and generate x and say it's a square, x times x, and show that list of numbers. Okay, you'll sometimes see me use the pipeline operator. So that's where you might have some data like this, and you pipe that into the show function here. Okay. And you'll sometimes see me put in pipelines of operations between some source of data and some output result. So this little pipe function here is nothing magical. You can actually just define it in F# like this, that you take some object and some function, and you apply the function to the object. Okay, so it's just putting things around the other way. So we might take the list of input coming in, and for each element, we'll do again let's take this and the cube of the data here. Actually, we'll generate x times x, and it's x times x times x. Right? And we'll show that here. And sometimes you'll see extra steps being placed along the way, for instance, filtering here. So we might want the ones where x is even. And you'll see a lot of functional abstraction in F#, where you take some expression like this, cube of x equals x times x times x, and we'll do the cube of x here. Square of x is x times x. Okay, you're probably wondering how does it know it's working over integers. By default, these operators work over integers. You can if you want them to work over other types, you generally qualify them like so to indicate what kind of numbers you're working with, and then you'll get an error here because the input is an integer, but we have a float here. Okay, so the other thing you'll see is that we're going to be using events in F#. So let's create ourselves a form. Here. We'll set the top, move this window here. We'll set the topmost to be true and the visible to also to be true. Okay, so there's a form. And now we'll take a look at, say, the text on the form here. So to be hello TechEd. And there. We have the text here. And we'll attach an event handler to the form. So for instance, we can take the click event, and unlike C#, events in F# are first-class objects. As we'll see, you can take events and you can take the event stream and you can get an observable or an event and work with those in a compositional way. And we'll take a look at that at the moment, but we're just going to do the add a handler to the click event to start with. So we'll take the click event and we'll add a handler, which every time we get the event args here, we can show the event args dot x and args dot y, except that we want the mouse click event to get the x and y. And now as we click over on this form, we'll see we're getting the data coming across over onto the right-hand form. Okay, so we've created ourselves our Twitter stream. And what we're going to do now is take some of the elements that we've learnt about taking data and putting it through pipelines and construct a little analysis of the stream of tweets from the public fire hose from Twitter. So the first thing we're going to do is take the tweets as they come off the live Twitter stream and simply dump the text of the JSON text as it comes through the stream. Dump that straight into the window. And then we can, at any time, we can ask to stop listening, and that will stop the sending of the stream. Now, for this talk, I did add that we clear the screen here because Twitter tweets tend to have a fairly high probability of showing things that you don't particularly want to show if you stop it at a random point. So I learned my lesson in Sweden. If you watch the Swedish Tech Days talk very carefully, you'll see a very quick movement on the keyboard to try and clear the screen. So let's put something else in the pipeline instead of just showing the tweet. Let's put a parse of the tweet in, and that's a function we've defined in the library. It does a little bit of JSON deserialization. It takes a string, and the parse might fail, so we can get a tweet option. So an option in F# is just, well, either you get it or you don't. It's a bit like a nullable, but you can use it with any type. We don't really like nulls in F#, so whenever you want the notion of something's not being there, you tend to use this option type instead. So we can take the stream of tweets and we add the parse of that in, and now you start to see a more structured, strongly typed view of the tweets. We have the user, the status state, the actual status. We have a bit of information about the user, how many friends they have, how many followers, what date they joined Twitter, and so on. So we can stop listening to that. So now what we want to do is to build an analysis about the words that are occurring in Twitter tweets. So to get the words, we're going to need to start splitting strings, and you all know how to do that in .NET. We want to split split a string and remove the empty entries. Now again, in F# you'll often write little helper functions that will kind of do this kind of routine thing and take a string and give you an array of strings back. And and now we can test that function. F#'s very hands-on. When you write a little function like that, it's very typical to construct a little test case, either a totally ad hoc test case like this one, or something you're going to start to develop into a more, eventually move over into your NUnit or your other kinds of testing infrastructure. So you can take some text and split it apart and have a look at what it's like, or you could maybe, if you didn't have that window hanging around in your development, you might just put it down in the interactive window down below and display it down here, which is what we expect. So now we're going to go through and we're going to choose the successful tweets. Choose is like map, except it throws away the ones that don't succeed. And then we're going to map through the tweets and we're going to get the status field out and we're going to apply this words function to it. And that lets us see the actual, just the words that are coming through the stream. You can see lots of different languages coming through, which is always a very interesting part of the data stream. So let's take a larger pipeline here. So we're going to choose the successful, let's have a look through the pipeline to see what's happening. We're going to choose the successful parsers. We're going to get the words out of the stream. And we're going to do, this is one of these sort of magical operators, this sort of event.histogram. That means as the events come through, we're going to keep a little bit of state on the side, which builds up an incremental histogram of the words. Okay, so we could take want to know a little bit about that, we can take a look at the types here. We have a event, which is giving us a map. It's like it's a map of the dictionary of how the grouping of the events. And we're going to visualize that every 10 tweets. We'll throw the histogram away 9 times out of 10. And then we'll take the top 50 entries to the histogram and continually show that over on the right. So let's take a look here. So as the stream picks up on its data source, you start to see the structure of the data that's coming from Twitter. There's a bit of a competition here between retweet A and the, and then some other language words. And you can immediately start to think of all kinds of analyses you might do on this data. It's very interesting to look how the languages, the words change during the day. As the day progresses around, the cycle progresses, then you get different languages being emphasized at different populations are more active on the stream at different times of day. This is the place where I first learned about the word Justin Bieber. I gotta admit. So I think beaver came up, and I thought, that's why are the Germans talking about beavers? Okay, right, so I hope that gives you a feel for some scripting with F# 2.0. As I said, this just scratches the surface of what you can do with F# 2.0 as it is in Visual Studio today. You can take this and you can script an awful lot just on the .NET framework and get really a lot done. You can also build much bigger applications. F# is largely written in F# itself. The compiler certainly is nearly all in F#. The Visual Studio tooling is nearly all in F# on top of the Visual Studio libraries. We also have some C# and some Visual Basic components, so we use that interoperability all the time, and it is no problem whatsoever. Very smooth to use. So what's F# for? I've given you a taste what you can do with it, but what's it really for in the context of the .NET platform? The we have been spending time this year really trying to clarify, what role are we looking at? And this is partly, it's an important question, especially because of this, there's a lot of work in these client-side technologies at the moment. We've got the phone big explosion of sort of client-side phone technologies and the sort of the Xbox, XNA client-side technologies. And is F# a client-side language? Is it a server-side language? Where are we really aiming at in the spectrum? Is it a scientific computing language? What's it really about? And as we talk through these questions and looked how people were using F# 2.0, we really came back to a theme which was a core part of the theme of our planning for F# 2.0, which is about F# and analytical engine components. The place where F# really seems to give major productivity benefits is in this kind of analytical engines that underlie finance computations, that underlie games sometimes, that underlie bioinformatics and scientific computing, that underlie a lot of the uses of machine learning algorithms in places like in the sort of services that Bing and Google offer. So one of the most successful uses of F# at Microsoft is actually to do with the Bing advertising engine and the ranking of, in particular, the analysis, the machine learning analysis that determines whether our prediction about whether users will click on particular ads or not. And that's absolutely critical to the business, and the algorithms were both prototyped and deployed in F#, and also they were subsequently, for the very front-end servers, the algorithms were rewritten in C++, which is fine for those servers because those are primarily C++ implemented. But the F# code continues to power the back-end, some of the back-end analyses in that particular structure, and we're very, very proud of the role that F# played in that. So let's take a look at what we mean by this theme. You can take a look at the F# 2.0 in the enterprise white paper that is available on fsharp.net if you would like to see, it's a short white paper, but really capturing this theme about analytical engine development and how we see that playing out with F# 2.0. But let's take a look at this. This is from Simon Cousins, who works for a power company in a UK European power company called Eon PowerGen. And he's written this very, very nice summary of this application, which is an engine that helps balance the national power generation schedule for this, one of the biggest power suppliers in the UK. And the calculation engine was written in F#, and no doubt there was a whole lot of C# and VB, and I'm not sure what else around in that application architecture. Or perhaps the component was immediately published as a service of some kind, or even as a COM component or some other kind of component. There will be some F# core and then some boundary, web boundary, a COM boundary, some kind of boundary where you don't really know it's F# from that point. And he wrote up why F# was so effective for this application, to address the complexity at the heart of the application, and pulled out how many of the features, especially a feature called units of measure, really helped reduce the bug count in this application. And in particular, he actually had 0 reported bugs in this application after it was deployed, which he said is unheard of in the industry. And he actually had to ring up the team who he deployed it to check that they were using it, because he wasn't getting any bug reports back, and they were using it, and it's a great result. There's some official write-ups on the Microsoft site about some finance companies using F#, Grange Insurance, and a large company which, for various reasons, had to remain anonymous, over on the right, but where they have many people using F# to great effect. That's primarily in their quant analysis groups. So if you imagine inside an organization, if you have a group, a company which is building .NET software or building COM components or some other standard architecture, then they have a choice. What are the quants, which language are the quants going to work with? And F# is very appealing to that audience as a productivity language which can integrate with the rest of the architectures that are being used very seamlessly, and also with all the Visual Studio tooling that you get. Another nice example is biotech. This is a quote from Darren Platt at a startup called Amaris Biotech. Darren is a very experienced biotechnology engineer, used to run the biotechnology biocomputing group for the largest sequencing lab of the US government in California. And he has moved on from Python. He was the person who first actually introduced me to Python quite a few years ago. But he's moved on to F#, and you can read the quote here: F# has been phenomenally useful. It's like a drug. I would be writing a lot of this in Python otherwise, and F# is more robust, 20 to 100 times faster to run and faster to develop. And this is not surprising, given that it's a strongly typed language with a lot of the scripting characteristics, a lot of the productivity characteristics of Python. Okay, so you've seen some of the basics already. I just want to draw out a couple of things. First of all, white space matters in F#. It's a very important thing to know, probably up front. That means this is a badly formatted F# program, and you have to write it like this instead. So you have to get things lined up. And in general, this is great because it brings a clarity to the code, and while giving you that lightweight scripting syntax. It's kind of gives you the best of both of those worlds. This is an F# application. You can compile this. If you can take that program and just run it through the F# compiler, fsc.exe. You can do this with Visual Studio 2010 today, and just open up the command prompt with the settings, and fsc.exe is there. And you can also run the F# interactive shell from the command line. And you can also just create a project in Visual Studio and hit F5. You've seen some programming like this where we create a form and then we add. You'll notice we use open instead of using. That's just a heritage thing from the ML family of languages which F# descends from. You've seen pipelining, and you've seen me construct pipelines like this. It's a very common idiom in F#. One thing you haven't seen is object-oriented programming in F#. We're very proud to have an object-oriented programming model that is very succinct and very declarative, and I think you can write extremely clear and beautiful object-oriented code in F#. Here's a sample of sort of a merging of objects and functional programming. We have at the top here, you see the inputs. This is implicitly defining a constructor here. So you don't have to define fields for dx and dy. They are implicit because the values are used outside the constructor down there. There will be fields for these. We create an extra field here, which is part of the object internals, which we just assume we're going to store away the dx squared, dy squared. For some reason, we decide to store that as an extra field, pre-compute that. And then we have the members. The members here are the public API. This let is private, and the members are public here. So they're the exported properties, the v.dx and the v.dy. The v dot is just naming the this variable. You get to choose what the this variable is called in F#. And we don't use it over on the right in any of these examples, but you could. This length is also a property, and this v.scale is a method, which happens to create a new vector, which is scaled by, each of the elements is scaled by k. Okay, so one of the things you'll see in F# is asynchronous programming, and we're all very happy that C# is joining us in the lovely world of asynchronous programming, and Visual Basic too. Now, Lucian will kill me already for having not said that Visual Basic up front, that the Visual Basic team were so active as part of the effort to bring asynchronous programming into C# and Visual Basic. I'm always being reminded that it should be VB and C# are joining us too. So this is such a wonderful construct because these reaction points in your program react to a GUI event, or react to a timer callback, or query response, or HTTP response, or web service, or disk I/O completion. And you can build, it's this wonderful building block for building reactive programs, network-connected programs, user interface-connected programs. So this combination of functional, immutable programming and asynchronous programming leads you in all sorts of lovely directions. It leads you towards parallel programming, multi-core programming. I gave some tasters of that on the earlier slides. It leads you to server-side programming, where you have highly scalable servers which are receiving messages, doing some processing on them, and then perhaps calling some further back-end services, collecting the results, and then passing them back as a response to the request. And it also leads you towards agent-oriented programming. We have our agent model in the F# library. You can use agents today in Visual Studio 2010, in-memory agents, and it's a very nice model. I won't go into it further today, but I do encourage you to take a look at that. Here's a little sample of an asynchronous workflow. This is like an asynchronous method in C#, if you've seen that talk. But it's where we handle a request from a TCP client asynchronously, and we asynchronously write back to the header, and we start writing back, say, stock quotes every second, or every, we do a sleep between the writes. And this scales beautifully because we're not using threads, we're using continuations or using state machines and using the thread pool. So, say, serving 50,000 simultaneous TCP connections with, say, 10 threads on a high-end server. And you can create the instance of the server here and give it the asynchronous request handler here. This is using some types that are in the F# Power Pack. And these are these await points in the C# vocabulary. Okay, so I hope that's given you a taste for F# today. And for the next half hour, we'll be talking about the F# futures, information-rich programming meets functional programming superdrug. Now, there's no CTP today. One of the things we decided with this work is we would start talking about it before we put out a CTP. It's partly because it's a part of the research tradition. I'm at Microsoft Research. I also contribute to F# full-time. But we like sharing the ideas that are coming down the pipeline. We would love your feedback on what we're doing. And we've collected a lot of interesting applications of the work we're doing here from talking to people. And we're very excited about the direction that we're following here. So, I've got an imaginary coding challenge here. Imagine you have to choose your favorite strongly typed language and you want to build a class library. That's your job. That's your job as a contractor, is to build for, say, a school that needs to develop some chemistry components. Then it wants a class library with the information model of the chemical elements. How long is it going to take you to design that library, to document it, to code it all up, create all your properties, create all your documentation, to start to populate those objects with data? Where are you going to populate those objects? Which data source are you going to use to populate those? How are you going to download the data? And you start to get a feeling for the fact that the languages we're using, the frameworks we're using, are not particularly information rich. It's a long manual process to go and construct these information models, or our business objects, or whatever else we consider as part of our information models. But we want to do it much more quickly, say 30 seconds or a minute. And I'm actually not going to time myself because I probably won't make the 30-second limit. So let's take a look at what it would mean to be working in an information-rich language. So what we're going to be doing here is connecting F# through to a web ontology, a semantic web data store. It's just an example of one of many possible data sources we could be using. It's one called freebase.com. So let's take a look at, we have the web data. Now, what we've done here is we've referenced a component here, which feels like, it looks like a DLL, okay? It's got a .dll extension, so I guess it is a DLL. But it's a special kind of DLL, okay? It's a DLL which we're all used to, a .NET DLL having a fixed set of types. You can go to ILDASM and you can see what types it's got defined in the DLL. But that doesn't scale in a certain way. What happens when you come across a data source which has thousands and thousands of types in it? Okay, it's got millions of types, potentially. Okay, what about Facebook? What if you had a type for every person on the planet or something like that? We can talk about really wacky uses of this later on. It's not fresh. If you have to code generate, then you may not have the latest set of types available from the information store. So what we're moving to is a model where a DLL can be a provider of types. It can compute a space of types. Okay, it can compute a potentially very large space of types based on some backing data. Okay, so this is all going to already feel very familiar because this is just what the code generation tools that we use, the database mapping tools that we use, that's sort of what they do, except they actually generate physical code. But we're moving here to a model where we're computing a space of types. So this is actually a very small DLL. It might be 100K or so. There's only one or two types defined in it, which is these adapter components, which adapt our language to connect to this data source, and so it's an adapter component which takes this ontology, this schematized data source, and pushes it through and presents it as if it were a set of .NET types. And it does this en masse for an enormous amount of data. So we've not just got our chemical elements, which we can find down here under chemistry. Probably the biggest danger of this work is that on the way to doing your job, doing your contract, you're going to get distracted and suddenly realize you can do all sorts of other things as well. For instance, you might be a comic book fan who wants to start writing comic book applications, or you might be a baseball fan here who wants to start writing a mobile phone or a slate application to do with historical baseball figures and their relationships to each other. Now, so you can see here that through a very small adapter component, you can connect the language, the programming experience, to information sources which are so much richer than the ones we can ever define by hand. Okay. These are enormous. They're ultimately the source of many of these. There's several instances of these kind of data sources around, but the source of a lot of the information is Wikipedia originally. So the data you're using is actually curated. You know, you've got an army of people out there generating this data for you and putting it in a sufficiently structured form that we can program against it. Okay, they don't realize they're doing that for us, because they're busy organizing all that data on Wikipedia. This is one example of a data source. It's not just Wikipedia, but let's say all that data on Wikipedia, they're busy organizing it mainly for the purposes of visualizing it. Okay, they create nice organized tabular displays and the like on Wikipedia, and it all looks good. But that's actually the structure we need to be able to program and query and have a typed representation of this organized data. So we can come here and let's take a look at our chemistry, get our job done and go to the chemical elements, because I've taken way more than 30 seconds so far. So let's pipe this here onto this show grid function. And it's starting to get the chemical elements down here and downloading the data set. And there are these funny elements at the start, which I think are the elements that haven't actually been discovered yet, or at least haven't been given names. And we start to get down to the ones that are more familiar down here. And this is a pretty good object model here, because it's, if I was doing the chemical elements, I probably just would have done the atomic numbers and the boiling points perhaps and a couple of others. But this has got really a lot of information. It's got all the isotopes listed here and melting points and a whole lot of other things. Okay, and some sort of more human information, such as the discoverers and discovering countries. Okay. Okay, so that's our chemical elements. We could equally have done quite like moving up the scientific chain and getting the amino acids here over on the right. So you start to get a feel for the kind of data that's available in this particular data source, and at least how it feels like to program with this. Now, one of the key things to realize is this is working in a strongly typed world, so that as we write a query like this, so we're going to take the chemical elements and start filtering them. Then we haven't actually got a chemical element yet. Okay, this E, we haven't got an E, we've just got this function that's going to take an E. And we can start working, it knows it's a chemical element because we're in a strongly typed language, and so it can give us the completion menus and the red squigglies if we make mistakes. So if we try to, for instance, E dot, if we take, this is a nonsensical thing to do because this is not a Boolean, we're not filtering properly, it's a nullable float, and we get a nice error that this doesn't make sense. If we make a mistake like boing point here, then we get a nice red squiggly saying that that's not defined. Okay. And the other crucial thing about strong typing is that it is a chance to propagate meta information through to the programming. So we get these nice descriptions being drawn from the web ontology down here of the descriptions of the particular property that we're looking at. So strong types aren't just about program correctness, they're not just about performance, they're about all the IntelliSense and all the coding time hints that we're giving to programmers. Okay, so we can execute this. Now it turns out some of the elements for some reason don't have an atomic number listed. Now that seems pretty strange to an element for me, but that it just shows you data is dirty. Okay, even a basic data set like this has some kind of minor glitch in it and you need to filter it, and this is really where we have to have programming tools around to work with our data streams. If data was perfect, then I perhaps wouldn't believe in quite so much in the crucial role of programming in highly data-oriented work. And of course, we want to do more than just, say, presenting the data in an application. Over on the right, we might want to analyze the data and visualize it. This is a correspondence of the elements in order of their atomic number, taking their names and corresponding them with the number of isotopes that they have. You can see that the number of isotopes drops away as soon as the elements become radioactive towards the end, down over this side of things. Okay. So I hope that's given you a bit of a feel for what an information-rich programming experience it can be. A typed information-rich programming experience can be like. So we do have to stop and think how, if you needed to access that web service today, it's ultimately a REST API. So you have to do JSON deserialization, and you have to do network stream requests and a lot of munging on strings, and even just to get the name, the boiling point, and the atomic mass out of the data stream would require this kind of code in F# 2.0. and even more code in C# as we have it today, that it's really a reminder. When I go and visit customers, it doesn't matter what language they're using, half of their code is data access code, okay? Really, so much of the complexity of what we're doing is about getting data under the type discipline of our languages. So the magic here is this provider architecture for types. So a type provider is a design time component that provides a computed space of types and methods. So it's a compiler or an IDE extension. You can think of it like that. You can think of it as an adapter between data and services and .NET languages. So F#, of course, still contains no actual data. It's just got some providers to connect to data sources. But it's an open architecture, and that's really part of the magic of this. You can write your own type provider, and very powerful type providers can drop out in 100 or 200 lines of code, depending on the data source that you're connecting to and how easy it is to access its schema. So as the next example of type provision, we're going to kind of step up a level. We've looked at accessing one data source, a very big and rich data source, but now we're going to look at a directory-based type provider, which is going to be a type provider for the entire Azure data market, Windows Azure Marketplace data market. And this is this wonderful new initiative. It used to be called the Dallas project. but it's become a major part of the data strategy at Microsoft that we are really talking about sort of professionalizing the provision of data on the web. And it really is a wonderful initiative. So you can go and visit the data mark by going to this URL. And you can sign in with your Windows Live ID, and you can sign up for various data sets. Many of the data sets are free. Some of the data sets are pay for. They may have a free number of queries, and then you start paying after you make a certain number or certain sizes of queries. They come with a service guarantee, which is important. I believe it's normally a 1-year service guarantee that the schema won't change for a year, and they'll be available for a year. I'm not sure. It probably varies from source to source and according to how much you're paying for the particular connection. Now, if you want to use this from code today, you have to go somewhere into the website and you have to press a button which says download C# code for accessing this data set, and you get some generated C# code, and you have to kind of put that into a project and start managing it and so on, and you can kind of guess how the rest of it will go. And let's take a look at the kind of experience we can construct instead with F#. Now remember that your colleague who's using C#, for instance, is going and manually downloading code from a website, okay? And what you're doing is simply going Windows Azure here, because we've referenced the type provider here, which gives us the whole data market in our hands. You go Windows Azure, and you go to the marketplace, and you go to the data market, and you have a look what data sets are there, because that's what they have at a data market. And you get all the data sets in your language. So you can go through, and you can, if you don't get distracted by sports and games again, which turns out these are the ones often that actually cost the money because they're the live data sets. The static data sets, the statistics ones tend to be free sometimes. So for instance, you can go through and you can get your statistics data sets, and you can start working with these directly. And it's actually an amazing, the data market is incredible, a wonderful set of data sources. They're all provided as OData streams, and underlying this, there's all the code to access OData streams. It's really, really incredible to be able to have this data in your hands so easily. Okay, so we can go to statistics, and for instance, there's the crime statistics in the United States. Not a terribly positive topic, I'm sorry. It was just the first on the list, so it was the first one I started working with here. And you actually end up writing this kind of code. You open the data market. You do have to use this generate tag, which just means there are some real .NET types being generated here. So let me just load this up and take you through it. So we reference the data market. We open some namespaces. We open the data market namespace. We get the connection to the particular crime data set here, and we create a service container for the crime data. And now once we have that, we can start working with the OData stream. We can get to the city crime table here and take a look at that particular data set here, which is the first 100 elements of the city crime data from the States in 2006 to 2008. And then we might start writing queries over this. So we might write a query for where the state is New York in 2007, and then we can take a look and maybe pipe it through to a charting application and look at which these are not normalized by population. So we're just looking at the raw crime statistics for different cities in the States, and similarly, you might build other visualizations of the data from this point. Okay, thank you. Okay, but the important thing to note here is just how immediate and how strongly typed and how easy it is to access an entire data market of information. So what do I've given you two examples of type providers. For what we're actually planning on shipping in this next version of F# or in the future version of F#, which will have this work, is a set of more practical, I think, more focused type providers on enterprise programming scenarios. We will ship the ones, we're planning to ship the two we've shown as samples, but the ones you would expect to find in, say, in Visual Studio are more like this, where you can make a service reference to an OData service simply by a very code-focused declaration like this. If you want to get the Netflix OData service, you simply just get out the type provider for OData, and you give it this parameter saying what service is being connected to. And then the types for the service just get created on demand magically behind the scenes, and you don't ever actually see the code generation process. So similarly, it will come as no surprise that we would focus on SQL data as well. So if you want an entity framework connection to a particular SQL database, then all you'll need to do is get the connection string, give it to the right type provider. You'll have strongly typed programming against the SQL database in a very simple and declarative way without reducing the use of the Visual Studio tooling project kind of code generation tooling that you would expect to see for that kind of work in C#. Very interesting application of this is for SharePoint programming. You can simply, Maya is one of the sites on the Microsoft internal network. You simply point the type provider at a particular SharePoint site, and then you can get strongly typed programming against all the lists, the web lists and the like on the SharePoint site. As part of doing this work, it's very interesting that when you make a language information rich, then you get a kind of a sequence of demands from people. They get the data in their hands, and one of the first things they demand is a charting library. Okay. Now, we're not thinking of putting a charting library in the box with F#. There is one already, the charting controls that I've been using, but there is this wonderful thing called F# chart, which I've been using here, which has been released on my blog, which is this scripting library over the .NET 4.0 charting controls. One of the other things that we get is requests to have better link queries in F#. We have link queries for F# 2.0 in something called the F# Power Pack, but we're taking that work and really polishing it up and adding some syntax into the F# language to allow you to write queries like this. We're doing it balancing the tradition in F# for how to do this kind of work with the needs that we really want C# programmers to be able to take C# link queries and translate them across reliably and accurately into F# link queries. So declarative link queries. It's very much constructed so that what's between the curly braces is what gets executed on the server, is what makes up the query. And so you can see that you can do sorts and takes and the like in the query syntax here. Okay, so I'll finish up now. So the vision for type providers is this information-rich world of web data and data markets. And one I haven't shown you today is the use of type providers to access WMI information. When we have this, F# becomes something like a strongly typed PowerShell. Okay. Suddenly you have all this network information available in an entirely strongly typed way. If you'd like to see that demo, come up and see me afterwards. I've got it here on my laptop. You can see some sort of WMI PowerShell-like programming with F#. So we want this strongly typed and without explicit code gen and extensible and open. And extensible and open means you might use this as a sort of to host against a spreadsheet, for example. We've done some samples like that. To host against web services. WSDL web services are, of course, schematized, or some sort of schematization of REST services. CRM data is another fascinating use. Social data is an incredibly interesting use for this kind of mechanism. and SQL, of course, and XML being highly important pragmatic ones. So to summarize, the world is information rich and our languages need to be information rich too. And we have sort of a manifesto of consume anything directly, strongly typed, and no walls. Sort of blow away those walls between you as a strongly typed programmer and the world of data and information on the outside. Okay, so F#, it's a fantastic addition to Visual Studio 2010. I think I've been very happy to bring it to people. It's major contributions in parallelism, and I hope I've given you a taste of a data-rich future ahead for the language. Here's some books about F#. There's F# 2.0. You can sort of take your pick from all of these very good books. There are also good online books that are available. There's one called CTO Corner, and there's also an F# wiki book. Both are great. And here's some of the related tracks and resources, usual thing. And there's the tag. And very glad you came along. And I don't know if it's a tradition to take questions here, but I would have time for 1 or 2 questions if anybody wants to ask in the audience. But thanks for coming along today.